Hello, welcome back. In this segment, I will introduce you to the Modus Tollens rule, which is one of the rules of natural deduction. It's not a foundational rule. We can derive this rule from other axioms we have discussed so far. I will prove that. First, let me give you an example. If Abraham Lincoln was Ethiopian, then he was African. Lincoln was not African, therefore he was not Ethiopian. So from a sort of a conceptual understanding point of view, we can convince ourselves this is correct. Okay, I'll give you my intuition here, right? Suppose you have set of all Africans. Let's just put one set of all Africans here. And within this is, say, Ethiopian. What we are saying is that the outer circle is African, the inner circle is Ethiopian. If somebody is not in the outer circle, that means they are not even African, right? So they cannot be present in inner circle because inner circle is contained within the outer circle. Okay, so that's the intuition. So if somebody is not here, right, they can't stay here. All right, so let's formalize this example. So we have two propositions here. The first proposition is Abraham Lincoln was Ethiopian. So P stands for that. And second proposition is related to whether he is African or not. So Lincoln was African. That's another proposition. So we can now write this English sentence as if P then Q, right? From the first, if Abraham Lincoln was Ethiopian, then he was African. So that's P implies Q. And then we are also saying Lincoln was not African. That's the not Q. And we are concluding that he is therefore not Ethiopian. Okay, that makes sense. How do we prove this? I'll show you how to prove this using the proof tool. I have created the problem. P implies Q, not Q. The conclusion is not P. Okay, let's try to prove this now. We have the premise P implies Q. That's the first premise. The second premise is not Q. What I'm going to do is I'll start with P. I combine 1 and 3 using the implies elimination. Okay, so I'm going to eliminate implies from line number 1 and 3, which makes sense because if P is true, P implies Q, that means you have Q. All right. But now, if you look at it carefully, we already have not Q as part of the premise. And we also arrived at Q. That means we have a contradiction. You can't have not Q under Q. Okay. And we are introducing a contradiction rule from line number 2 and 4. Okay. Let's check the proof to make sure we are on track so far. Okay. No errors. We have not yet reached the conclusion. So we reached a contradiction. Why does this contradiction occur? This contradiction occur because we started with the wrong premise. We said P is to be true. And we combine P with P implies Q to arrive at Q. But if you take statement number 2, we have not Q. And statement number 4, we have Q. That cannot be possible. You cannot have both Q and not Q to be true. Therefore, our contradiction arrived, which means number 3 must be wrong. That's the wrong assumption we started with. Okay, so now I can go ahead and add a statement that it is not P. I have a not introduction at line number, from line number 3 to 5 reasoning. Okay, because of the line number 3 to 5, right, I got a contradiction. Okay, from P, Q, I end up with a contradiction. That's the reason I put one I 3 to 5. That means I'm introducing a not. And now let's check the proof. Yeah, we're done with the proof.